All right, so I would like to evaluate the arctangent of square root of 3. How in the heck is that going to happen?
Look at our right triangle.
Okay, so I need to be looking in a right triangle. Okay, so draw yourself a right triangle. And then what? Okay. How should I label this triangle?
30, 60, 90.
Okay. Maybe look at the 30, 60, 90 triangle. Or I could say, all right, here's an angle. That angle is going to be tangent inverse of square root of 3. You guys all good with that? You all believe that thing is an angle? Why should that thing be an angle?
Because inverse of cosine tangent or whatever gives it an angle.
Yeah. So this is an inverse trig function, right? So it takes a ratio of side lengths and turns it into an angle, right? So what's the ratio of side lengths? Square root of 3 over 1. So what do I know about this angle? I know it's
Opposite or adjacent.
good. There's a tangent thing, right? See that? So I think that this should be square root of 3 and 1. Right? Because this guy's tangent is square root of 3. So its opposite over its adjacent is square root of 3. Cool? So now what? You can find the hypotenuse with the Pythagorean theorem. What is it?
2.
It's 2. How do you guys know it's 2? Because it's a 30, 60, 90 triangle, right? Okay, so which angle am I sitting at here?
60.
Yeah, that's the 60. So this is 60 degrees, or it's perfect. 5 over 3. Cool. Questions, deals?
So when we see one number in there, can we assume that it's actually whatever that number is over 1?
Yeah, just like when you're multiplying fractions, right?
Cool.
Yeah, you can throw the over one in there if it helps you think.
But with a triangle especially, that means like, okay, one of these sides is 1.
Yeah, whenever you're doing an inverse trig function or something, I really recommend the over one there. I think that's a good philosophy. Other questions?
What if it doesn't come out to be a nice triangle?
Perfect. What if it doesn't come out to be a nice triangle? Then in some sense, it's as simple as it's going to get. What else could you do? Yeah, so if I had done a similar problem with square root of 6 or 10 or something that's kind of inconvenient, right? Then, yeah, I'm going to plug it in the calculator. What's the difference between what I got here and what I would get in that case?
Takes more steps.
You don't understand the other one.
Yeah, good. It's mostly that I'm approximating, right? So instead of equals 60 or equals pi over 3, I would write is approximately, In the same way, right, that we would do something like this. Right, if I asked this in a pre-algebra class, 1 over 3, they might say is 0.33, right? Approximate. You guys see that? The right answer, right, that actual, honest-to-God, exact equality answer is this, right? But of course, we could approximate. So if I asked you to evaluate something like tangent inverse of square root of 10, right? In some sense, this is as evaluated as it gets, right? Or you could approximate.
So we could just circle on them.
Yeah. This is done. I cannot go further with this and maintain equality. You guys good with that?
Yes.
I would much rather if you all learn to err on the side of exactness rather than on the side of kind of approximation. Cool.